Morning everyone. Today we are gonna to learn about the secant method. In previous two videos, we have completed the bisection and regular falsy method. In today's video, we will be learning about the secant methods, advantages, disadvantages, algorithm, program, and do the secant method with one example problem solution. Okay, so what is the objective of the secant method? The goals of the secant method is to aim to find approximate root of non-linear equation where exact analytical solution are difficult to impossible to obtain by iterative refining approximations. We can achieve highly accurate result for complex mathematical problems. The primary goal is to improve the root approximation iteratively by drawing function curve. Each iteration brings us closer to the actual root by finding where the secant line intersects the x-axis. The secant formula. The secant method uses an iterative formula to approximate roots by finding where the secant line intersects the x-axis. The next approximation x n plus 1 is calculated using two previous points, eliminating the need of derivative calculation while maintaining efficient convergence. The now advantages of secant method. The secant methods offer significant computational advantage over the other root finding techniques by using secant line approximation between successive points. It achieves the efficient convergence without the complexity of derivative calculation. Simple and efficient iterative process is straightforward by using only function values at 2 points. The simplicity makes implementation easy while the remaining highly efficient of many practical roots finding problems in engineering and scientific computation. Its fast convergence. The secant method converges more quickly than the traditional methods like regular falsy method and bisection methods. Its superlinear convergence rate means fewer iterations are needed to reach the desired accuracy, making it computationally efficient for solving nonlinear equations. No derivative required. Unlike Newton's method, the secant method does not require calculating derivatives. This makes it ideal for functions where the derivatives are complex to compute or unavailable. Only need functions evaluation at 2 points are needed. The disadvantages of secant methods are initial approximation requires too good initial approximation to begin the iteration process. Poor initial guess can lead to slow convergence, divergence, or convergence to an unintended root of equation. Convergence issue. The method may diverge if initial guesses are not sufficiently close to the actual root. Unlike bracketing methods, there is no guarantee that iteration will converge, making it careful selection of a starting point and critical for success. Stability concern less stable than bisection since it does not maintain the bracketing of root. Now we will solve one question which we have also solved by using bisection and regular policy. Now we will do it with a secant method. So our question is x square minus x minus 1. The function x square minus x crosses 0 at 2 points. By applying the secant method with appropriate initial guesses, we can iteratively converge to the positive root with high precision. The first initial guess we take is x0 equals to 1. If fx0 f of 1 square, putting the value, the function value is negative at this point, indicating that the root lies into the right of x of 0. The second initial guess x2 is that we will do the function at x2. uh, the function value is positive at the point, confirming a root exists between x0 and x1. So there are two initial guesses we have taken. Now iteration. Applying secant formula using our initial values x0 and x1 to compute the next approximation. The formula x2 equals to x1 minus fx1 minus x0 upon fx1 minus fx0 gives us our first improved estimation of root. Computing x2 equals to x1 minus fx1 x1 minus x0 upon fx1 minus fx0. So here x2 comes 1.5. Now evaluating 1.5 here, x0 x2 minus x1, and it comes f 1.5 equals to minus 0.25. Building on our first iteration, the result of x2 equals to 1.5, we now applied the secant method formula using x1 and x2 as two most recent approximation. This iteration brings us significantly closer to the actual root of the equation. Using the secant formula, we again calculate the x3, and after calculating the x3, we now do the same process, calculate fx3, and perform the iteration 3, where we can perform it by using x2 and x3. In this we find the x4 where with the desired formula we have studied, and evaluate the fx, and f of x, if it is you can see it is less than the tolerance or error value we have decided, so we can take the result that is in iteration 3 and declare it as the final root value. And now there is a iteration summary where we have calculated firstly x2, then x3, and then x4 at the and error calculation simultaneously. Here you can see error in x2 minus x1 is 0.5, which is large, and in x3 minus x2 is 0.1, which is also large. And if you calculate error in x4 minus x3, it is somehow less. The error decreases rapidly with the each iteration, demonstrating the fast convergence of secant method. Starting from initial guess, x1 method converges to the root x equals to 1.618 in just 4 iterations. Now the final answer is x tends to 1.618, which is closest. This result is remarkably close to the golden ratio. This equation is defining the equation for golden ratio, making this method significant result. The secant method effectively found its roots in just few iterations without requiring derivative calculation. Now we will go through the algorithm. For that we will start the program. Initial input initial values we will take, apply the secant formula that we have studied, and check if the value comes by initial formula. If you put it into the function that is it less than tolerance, if yes, then we will return. If not converged, update x and minus 1, and we will keep the values ahead. Like if we are firstly using x0 x1, so now we will be using x1 and x2, and then x2 and x3. If not converge, update, we will update this and repeat steps 3 to 5 until it converges, and output the root stop, then stop. Now we will go through the program. For that here we will define the secant. Firstly we define the function we have to return using lambda keyword, initial values, and the tolerance, and the maximum iteration. Now we find root equals to secant method, and mm, call the secant method function. Here the secant method function takes the argument and start the for loop and declare the values. Here x2 is calculated using the secant formula, and iteration information is printed here. If the absolute of x2 minus x1 is less than tolerance, then we will return x2, otherwise x0, and we will uh, mm, transfer the any increase the values like x0 x1 to x1 x2 and return x1. At conclusion, the secant method proves to be an efficient and fast routing finding technique for solving nonlinear equations. It offers a practical balance between simplicity and convergence speed, making it a valuable tool in numerical analysis without requiring derivative calculations. It provides a useful alternative to Newton's method and bisection method in many computational scenarios. Its applications are numerical analysis for root finding, engineering problem solution, scientific computations involving nonlinear equations, situations where derivatives are difficult to compute. Its key takeaways are efficient and fast truth finding techniques, does not require derivative calculation, useful alternative of Newton's method, practical substitute of bisection, and ideal for many real world applications. Thank you. If there are any question, you can just ask in the comment section. Thank you. Have a good day.